Hello everyone, my name is Lau. I will be presenting a topic on mobile ad hoc networking, milestone challenges and its new research direction. This page covers and acknowledges the material where the presentation borrow a reference from. I wish to highlight, as the title of this presentation suggests, the main part of the material comes from the first reference, which is the Communication Magazine of IEEE Year 2014. Other reference papers being quoted in this presentation are also listed here for the people who are interested to know more. This is the abstract of this presentation. A mobile ad hoc network is, in short, MANET was seen as one of the most innovative and challenging wireless networking paradigm. Actually, it's viewed as one of the major technology that will affect everyday life of everyone. Naturally, three fundamental questions arise. Why does it not have an impact on communication? What is stopping MANET from being successful? If it's not successful, so what are the research directions on networking heading towards? This is what this presentation is about. It's about understanding the working principle and motivation of MANET. We will analyze its strengths and weaknesses and what deter it from being successful. We review successful MANET device paradigm, and also lastly, new paradigm research direction will be looked into, and we end with the challenges. Okay, we have covered the forward abstract that goes through the agenda for this presentation. Okay, we will start with the state of art networking and what is a MANET and what is the motivation and vision behind. We will do a parametric review on its strengths and weaknesses. We will go through the three successful MANET device paradigm and milestone. We will analyze and review, namely the mesh, sensor, and the opportunistic network paradigm. We want to know what made them so special and successful in comparison with pure MANET. Lastly, we'll touch on to the new research direction and challenges. Where and what research direction are we heading towards? And further discussion on challenges on this research direction. Okay, let's start with the state of art of ad hoc networking. A mobile ad hoc network can be defined as a continuously self-configurating infrastructureless network of mobile devices connected wirelessly. As the diagram below shows, each device in the MANET is free to move independently in any direction, and will therefore change its link to other devices frequently. Each of them must be able to forward traffic unrelated to its own use, and therefore act as a router. The MANET uses IP routing and forwarding functionality to support general purpose internet model. It is best contrast with a infrastructure network. For this example, we will use a mobile GSM network, which has a backbone infrastructure managing and controlling the network. So if the infrastructure fails, the whole network will collapse. This is unlike of MANET, which is independent of infrastructure. The key takeaway is that the MANET is pure. No infrastructure or authority is assumed to implement any network function. MANET is taken as general purpose. It denotes that these networks are not designed with any specification in mind. That explains its internet-oriented model. Okay, so MANET looks good. So what's the problem? Okay, the primary problem is that a lack of realism both from the user and technical perspective. So from the user perspective, users are looking for multi-purpose networking platform in which cost is an issue and internet access is a must. However, MANET was developed originally by large-scale and military or civilian application, where cost was not an issue, and infrastructure was not taken to be available. That's why internet accessibility was not taken in consideration. And secondly, there are no application scenario to attract user interest, resulting in low user acceptance. Actually, there are no real or practical application or use case scenario defined. Lastly, the industrial or service provider, the motivation for them to use a large-scale MANET was not clear and strong enough. Basically, there is no market or ecosystem to drive the deployment of a large-scale MANET. So from the technical point of view, it's tough, if not impossible, to design a cost-effective, efficient network architecture and protocol. The fact is that we are dealing with a general-purpose network model, which gives us a wide diverging specification. Secondly, complexity and inefficient application is actually limited by the service provided by the TCP/IP protocol. So this is a known problem where MANET uses TCP/IP as a transport layer due to its reliance on internet model. There is also issues on simulation capability, as well as difficulty to simulate a model. Actually, to construct a real MANET test bed for a given scenario is expensive and limited. Simulation model, on the other hand, is more flexible but bring about gravity issue. Lastly, MANET does not represent a realistic and feasible option with current technology. So Actually, recent research shows that 80.11 can only achieve a horizontal of 2 to 3 hop with 10 to 15 nodes that diminish the benefit of having a MANET. Okay, we'll take a break here. In coming slides, we'll look into the 3 successful networking paradigms emerged from MAN network and the reason for their success. So the 3 network paradigms we'll discuss will be the mesh network, sensor network, and the opportunistic network. After which we will discuss this new research direction from a lesson learned out of the 3 network paradigms. The first network paradigm that we will discuss is the wireless mesh network. It is application oriented as shown in the picture on the right. The mesh network are built on a mix of fixed and mobile nodes interconnected wirelessly to form a multi-hop ad-hoc network. The intention is to provide a flexible and low-cost extension of the internet. The picture also shows a classical example of a 2-tier mesh architecture. The top tier is actually the mobile devices connected and rely on the bottom tier, which has a fixed infrastructure for internet access. Example of popular commercial application are public transport system and public internet access, especially for remote area. The main difference between mesh and MANET are MANET nodes are wireless and mobile, but mesh network actually use both fixed and mobile nodes. MANET is infrastructureless. Mesh, on the other hand, rely on a backbone infrastructure. Most traffic for MANET is actually node to node. For mesh network, it's actually node to gateway. In this slide, we'll look in some example. The first one is the transportation system. We can see a number of fixed wireless router used as access point together with the gateway, which form the backbone infrastructure. The mobile nodes are the public vehicle that connect itself to the access point to get the service provided. In the second example, we shall show how internet access for hard-to-reach area is done through mesh network. Actually, the mesh network is by hopping through nodes and finally to the required gateway. We can see that for the mesh network, the complexity is reduced by shifting away from the infrastructureless architecture to a 2-tier multi-hop network architecture. So now we have a wireless backbone infrastructure available to leverage on, and a mesh client can now enjoy network services by connecting to the network access point. So the main and the most important benefit is that the network management and control are now offloaded to the back-end architecture, which greatly simplified network design and mobility issue. The price to pay is that the mobility now is restricted to last hop, so you have to be near to the access point, which is fixed, or you multi-hop to it. And there's some sort of traffic distribution are required at the gateway and access point due to high traffic. The second network paradigm we will talk about will be the wireless sensor network. It's a special class of MANET with an intention to monitor and to control a range of events and activity. So the popular applications are the wild animal monitoring and hazard monitoring prevention system. So the main difference in respect with MANET is that the sensor network has a stricter timeliness compared to MANET. So there's a requirement to store data even if after the data is transmitted. So most of the nodes are identical for sensor network, but it's different for MANET. Data are synchronous in nature, whereas it's asynchronous for MANET. So we'll use a diagram to illustrate how a wireless sensor network works. So there are many wireless mobile nodes in the network. There are usually a node that is connected to the server. We call it a sync node. When the node wishes to transmit data, it actually jumps between adjacent nodes and finally to the sync node and to the server. In this slide, we'll show some example where wireless sensor network is deployed, namely the animal monitoring system and hazard monitoring network, such as forest fire and structured monitoring. The interesting note to note is that one of the world's largest wireless sensor network actually have more than 5,000 sensors connected to a base station. The wireless sensor network has complexity reduced actually by having a specific purpose, and is purely application driven. It results in a pragmatic approach tailored to solve a practical problem. So its research is always have a real development in mind. So benefit wise, by doing so, wireless sensor network usually have a low requirement of data rate, bandwidth and processing power. The node can be made very simple and compact. The limitation, however, the data timeliness is vital. So we need some form of data synchronization or shadowing, something like a time stamping sort of. There is also harsher requirement on physical size, weight, and battery life. So now we are the last network paradigm, which is the opportunistic networking. Unlike MANET, where mobility is an issue, when connectivity between nodes has to be maintained, OpNet use and exploit mobility for opportunity to get connected. Example of popular commercial application are the social apps using human mobility, and MANET, which stand for vehicular ad hoc networking. The main difference between MANET versus OpNet is that for OpNet, data is the delay tolerance and can be stored and relayed in the next available contact slot. That means that the node need not to be always be connected. For the case of OpNet, mobility is actually constructive, unlike MANET, which is a problem. So let's use a diagram to illustrate OpNet in action. So there will be a destination node that is connected resource such as the internet. Usually it would have some source node that is already connected to it. In the diagram, there is a disconnected source node that is looking for opportunity to get connected. As it approaches nearer, it gets connected to other source node, which in turn connects to itself to the destination node, and a link is established. In this slide, the pictorial view of OpNet example we mentioned earlier is also shown here, which is the social mobile network application, and also the classical VANet. We used to highlight that here that the idea of a human as a mobility mode actually brings us a first step to the people-centric network, which we'll discuss at the next section of the slide. OpNet has a reduced complexity due to the fact that the end-to-end path do not need to be well-defined. Traditional internet model can be dropped, and the best part is that mobility, which is a limitation in MANET, is a desired feature in OpNet. The obvious benefit is that we can eliminate mobility issue that is previously faced by MANET. Unlike MANET, OpNet uses a best hop approach, which do not need to maintain or to keep a routing table. For limitation-wise, it actually requires a certain level of mobility and density and contact time to work to obtain a certain level of QoS. So it's not suitable for application that has a low tolerance of data delay. We have seen the three popular wireless ad hoc networking. It is time to present a new research paradigm. We call it the people-centric networking. It is application-oriented. It's driven by the explosive growth of more smart mobile devices and the need for network technology that can naturally blend into people's behavior and daily activity. So it has reduced complexity. Is that they use a top-down approach. So as people needs and requirements are now the drivers, people themselves are the node. They are the connection. They are the resources. So also bring the possibility for opportunistic and cooperative networking. The key concept here is that we are evolving from a device-to-device paradigm towards a people-to-people paradigm. So let's look at this current research. It is mainly on two areas, namely the mobile phone sensing and phone cloud. For mobile phone sensing, it is also known as cloud sensing. This is where billions of user mobile phone is used as a data collecting instrument for real-world observation. Okay, the challenge here is to have an efficient model that is able to categorize mobility given uncertainty of future connectivity. Okay, it implies a shift from a packet-based to a message-based communication. Next will be the mobile phone cloud. It's a derivative of a growing cloud computing service model. It's an ambition of mobile device that is to seek cloud service for surrounding instead of data center to fulfill the demand for resource-hungry application. The challenge here is to use a different type of data dissemination strategy, such as a social behavior-based or a global optimization-based. So it's important to note that the security is a big issue and challenge for PCNet because of human direct involvement. We are coming to the end of this presentation. So let's summarize everything we have covered into a single table. We can see that from the table, MANET is losing research interest as explained in the previous slide. Mesh and sensor network are rather matured and reaching a saturation in terms of market relevance. We can see that PCNet and OpNet is uprising and growing and have a high research interest present. It's interesting to note that the OpNet actually naturally finds its way to PCNet as a need to exploit mobility. Okay, before we end this presentation, We believe in near future there are high possibility of mixing network paradigm together with variety of infrastructure-based network like the GSM, the cloud, giving birth to rich development of novel networking paradigm as we move towards a multi-paradigm era. Thank you.